Hi, awesome and amazing pre-AP, pre-cal students. This is part 2 of yesterday's worksheet. This is the part where we're going to solve exponential equations. Solving means you're solving for x. Equations means you'll have an equal sign. And exponential means you're going to have exponents. So let's check it out and see what we got. The assignment when we finish is to finish yesterday's worksheet, do page 2 from yesterday's worksheet. This is the solving part. This will be turned in as one assignment, not 2 assignments. All right, some strategies. Try to obtain like bases. If your bases are the same, then your exponents have to be equal. We refer to this as the one-to-one property. For instance, if I had 5 to the x power equals 5 to the second power, I would know that x would have to equal 2 because 5 squared equals 5 squared. That's called the one-to-one property. Because these two things are in the same position, they have to be equal to each other. Let's try. Here's one. We have 36 to the x plus 1. I could take 36 down to a base of 6. 36 is the same as 6 squared to the x plus 1 power equals 6 to the x plus 6 power. Now, what we learned yesterday, we reviewed some rules of exponents. When we have a power to a power, we multiply the powers. So 2 times the quantity x plus 1 gives me 2x plus 2. Don't forget to distribute. Equals 6 to the x plus 6 power. Now, when my bases are equal, my powers have to be equal. So this is called the one-to-one property. I know that 2x plus 2 has to equal x plus 6. So now we just solve. So if I subtract x from both sides, I get x plus 2 equals 6. If I subtract 2 from both sides, I get x equals 4. I could always check my work by plugging it into the original problem, and it should work, meaning the left side should equal the right side. Here's another one. If I'm going too fast, you can always slow the video down. 1/2 is the same as 2 to the negative 1 power. Remember what we learned yesterday about negative powers. Equals 64. I could take 64 down to a base of 2. If you check it out, 2 to the 6 is 64 to the 1/2 power. So 2 to the 6 is the same as 64. And remember, that's not 2 times 6. 2 to the 6. That's 2 times 2 times 2 times 2 times 2 times 2. And back to the left, I have a power to a power. We multiply. When you have a power to a power, you multiply your powers. And 6 times 1/2 is 3. So negative c is equal to 3 because I'm using the one-to-one property because they're in the same position and the bases are equal to each other, then the powers must be equal. So c equals negative 3. You can always check your work by plugging it into the original problem, and the left side should equal the right side. Here's another one. We've got a base of 2/3 on the left. So I'm feeling like if my base is 2/3 on the left, I would be wanting to have a base of 2/3 on the right. But if you notice, 9 is 3 squared and 4 is 2 squared to the 3x over 4 power. So I don't quite have the same base, but what if I flipped the right side over? So let me rewrite the left side. What if I flip this side? So what if I put the 2 squared in the top? It would become 2 to the negative 2. And what if I put the 3 squared in the bottom? It would become 3 to the negative 2. This is what we learned yesterday about negative powers, or or reciprocals. So I always think of it, if my exponent is positive, if I switch its position, it'll make it negative. So, and then we have to the 3x over 4 power. So now I have 2/3 to the x minus 5 power is equal to, this would be 2/3, the fraction 2/3 to the negative 2 power, to the 3x over 4 power. So what we learned yesterday was, if I have a fraction to this power of negative 2, it would be the same as the numerator to the negative 2 and the denominator to the negative 2 power. So that would be okay to put that negative 2 up there. So now what we want to do is recopy the left. It's just hanging out, chilling until the right side gets caught up. This would be 2/3. Now we have the same base. A power to a power, we multiply. That's negative 2 over 1 times 3x over 4. That would give me negative 6x over 4, which would be negative 3x over 2. Now that my bases are equal, I can set my powers equal to each other. This is called the 1-to-1 property. Whoa, what is that doing? This is called the 1-to-1 property. Negative, that's actually negative 1.5x. That might be easier for me. Minus 1x minus 1x. So negative 5 equals negative 2.5x. Divide by negative 2.5 and I get 2 equals x. We can always check our work by plugging our answer back into the problem. And the left side should equal the right side. All right, let's just move on past that. In our next problem, same thing. We're trying to get our bases to be alike. I see this base is 4. I could make 16 a base of 4. That would be 4 squared. There's my 16 to the x plus 3 power is equal to 4 to the 4x plus 7 power. Moving back to the left side, a power to a power, we multiply the powers. Make sure you distribute the 2. We get 2x plus 6. So make sure you distribute. 4 to the 2x plus 6 equals 4 to the 4x plus 7. When our bases are equal, our powers must be equal. So we are going to set the powers equal to each other. This is called the 1-to-1 property because they're in the same spot. Because they're in the same spot, the powers have to be equal. So we've got, let's subtract 2x from both sides. So we have 6 equals 2x plus 7. And let's subtract 7 from both sides. We end up with negative 1 equals 2x. We'll divide both sides by 2, and we get x equals negative 1/2. We can always check our work by plugging it in to make sure that it is correct, but it is. All right, moving on. Although this is an exponential equation, we will need logarithms to solve. LOL, it'll be fine. Let's review a little bit about logarithms. Recall that when we had something like 4 squared equals 16, to write that as a logarithm, we write log base 4. 4 is the base. The exponent goes over here. 2 is the exponent, and the answer goes after the word log. So if we were to take this problem and rewrite it, it would be log base 4 of 13 is equal to x. Logarithms equal exponents. This is called the exact value. if I were to check that in my, get a decimal value for that in my calculator, the decimal value is 1.85. Now you guys know how to do that from last 9 weeks. We can use a graphing calculator, or we can use Desmos. And if we put it into Desmos, remember under functions, we'll find miscellaneous functions, miscellaneous, and we'll find logs, logs base, and natural logs. This is one that we would want to use, a natural log. Natural log, my base is the E. My exponent is 4 minus 3x, and my answer is 6. So we would write natural log of 6. The base E is understood, equals 4 minus 3x. Let's solve for x by subtracting 4 from both sides. So we have natural log of 6, close parentheses, minus 4 equals negative 3x. Divide both sides by negative 3, and we'd have natural log of 6, close parentheses, minus 4 divided by negative 3 equals x. And the decimal value should be 0.74. This is what we would consider an exact answer. This is what we would consider to be a rounded off version, not exact. I don't know why it's boxing that, but anyway. All right, moving on. Let's see what else we got. Z substitution. So we have a problem here which looks pretty ugly. We're going to solve this problem by factoring, but that looks like a pretty evil problem to factor. So let's use something we call Z substitution. Let Z equal e to the x power. Let Z equal e to the x. So if Z equals e to the x, then if I squared both sides, Z squared would equal, and if I square this side, Z squared would equal e to the 2x power. Because a power to a power, we multiply the powers. All right, so Z squared is equal to 2x. So right here where I have e to the 2x, that would equal Z squared minus 15 e to the x. Well, we said e to the x was going to equal Z. Plus 56 equals 0. Boy, I don't know what it is doing. Okay, plus 56 equals 0. All right, now we can factor this. We'd have Z and Z would give us the Z squared. And we'd have minus 8 minus 7. And negative 8 times negative 7 gives us positive 56, but adds together to give us negative 15. And then we would have Z equals 8 and Z equals 7. However, we're not really after Z. The original problem had X's in it. We're really trying to solve for X. So let's use this. If we know that Z is equal to e to the x, then we would have 8 is equal to e to the x. And likewise, we'd have, if Z equals 7, we would have 7 is equal to e to the x power. Now we want to put this in log form. That would be natural log. My base is the e. My answer is the 8, and my exponent is the x. So natural log of 8 equals x is the exact value, and